Okay, so in this video we're going to talk about analog input and analog output, and we're also going to introduce the concepts of using loops in our code as well. So let's go to the Arduino website and see what it tells us about analog input and output. Specifically, we want to look at the analog read and analog write commands. So if we click on those, it's going to go into the details of it, and feel free to read through this. I'm going to go through the basics of it, and then we'll see an example here in a few minutes. But okay, so first, analog read. There are certain pins on the Arduino boards that are specifically set up to read raw voltages, and they're usually labeled A0 or A1, something like that. What the Arduino board does is it will read the raw voltages and it will convert them into a number, and it corresponds, for example, 0 and 5 volts into a number between 0 and 1023. So if you were reading a value and it was 5 volts, the reading would list out at 1023, and vice versa. If you're reading 0, it would read 0, and if it were something in between there, you'd get a number in between at the same percentage. So, you know, if it was 2.5 volts, that's halfway in between. It would be halfway in between these numbers at whatever 600 and what would that be? 612, something like that. No, 512, 511. So anyway, I think you get the point there, that the ratios are the same, but it converts it into a number, and then we can do things with that specific number. You know, we could convert it back into a voltage or some other useful thing, so that it allows us to read what's actually going on in the circuit, and we can print it out to a screen, or we can do math on it, or things of that nature, and we'll see that here in a second. Okay, so next let's talk about analog write. And to really understand analog write, you have to understand the concept of a duty cycle. And so to keep this as simple as possible, if you want to supply 3 volts to a circuit, or somewhere in between 0 and 5 volts, the Arduino board doesn't actually supply 3 volts. What it does is it turns its 5 volt source on and off in a certain manner that mimics 3 volts to the circuit. So the simplest way to go through this is, if you're at home and you're turning on and off a light switch, and let's say over a time period of 10 seconds, for 6 of those seconds you're keeping the light on, and for 4 seconds you're keeping the light off. That's called a 60% duty cycle. And that same 60% is what's being used by the Arduino to mimic a 3 volt source. Except instead of over a period of 10 seconds, it's doing it at 490 times per second. So it's doing it really, really fast. It's keeping the power on for 60% and then off for 40%. And what that does is mimics the 3 volts. And vice versa, if you wanted to do a 4 volt, you would find out the percentage, 4 divided by 5, and then you would use that as your duty cycle. So the next after that, the next most important thing to understand here is that the numbers that you want to use to set the duty cycle are going to be between 0 and 255. And we'll see an example here in a second that's going to make this easier to understand. But the basics is, if you're telling it 255, that means that you want it to be on all the time, or 5 volts. So you'd be supplying 5 volts at that point. 0 is off. So in our example of 60% duty cycle, or mimicking 3 volts, you would take 255 times 0.6 for 60, and you get a value of 153. So we would want to analog write a value of 153 in order to get 3 volts. So, okay, so let's do another one. Let's say we wanted 2 volts. We would do 2 divided by 5, and that gives us a 40% duty cycle, or 0.4. So then you take that 0.4 and you multiply by 255 and you get 102. So that would be the number that we'd want to use there. So that's just kind of a quick breakdown of how analog read and how analog write works. So now let's take a look at what the code looks like. So I've gone ahead and completely finished an example here, and let's break this down step by step so we can understand some of the stuff you'll have seen before, and maybe some of it you won't. So first at the top, we've got three variables here. We've had to change up a few things. I've had to change the pins from the last example because we need to use those pins that are set up to read analog and also write analog. There's also specific pins that can do, it's called PWM signals, pulse width modulation, and that's what we use those pins to do the analog write command. So I've had to change up the pins a little bit. First of all, we have light pin 3, and that's still going to be the same idea. That's where we're going to send the power out from to light up the LED. But now that's on pin 3. So now we have a variable called power. We're going to set it equal to 0, and voltage, we're going to set it equal to 0. Again, you can use anything for these variables, but I've chosen these because they make sense to me. Okay, so now down in the setup portion here, we're going to use our pin mode command that we talked about in the last videos, and we're going to set light pin to an output because that's what we're going to be sending voltage out from. And now we're going to designate pin mode A5 here. So this is an analog pin that I'm using. And we're going to set that to an input because that's what we're going to be doing the analog read command from. This next command is a command that starts the serial monitor, and I'm not going to get into too much into the specifics of this, but this is what allows us to see what's going on in the circuit. So when we read values, you can print them to the serial monitor. And this command just tells us that we want to start the serial monitor at the beginning here so that we can use it later. Okay, so now for the loop. We've got two different for loops here. And what these are it's the same concept as the main void loop here, except we're using them in smaller portions here. So let's go back to the website here, the Arduino website, and let's look at what Arduino tells us about for loops. So control structure, for loop. Okay, so the most important section is the part you see here, which is really kind of the syntax of how it works. Basically, there's a set criteria that the code checks, and as long as that criteria is true, it will run any code contained within that loop or within these outer parentheses here. It also includes a command you can increase or decrease a certain value in between each loop iteration. So for example, here you are setting your condition for which the for loop is going to trigger. So for our example, we're saying that when our variable power is equal to 0, we want this for loop to activate. And I guess I should say the end goal here is to get the LED to gradually get brighter and brighter and brighter until it's full on, and then go dimmer and dimmer and dimmer until it's 0, and then just repeat that constantly. So it's constantly dimming from 0 to full power and then back to 0, and then keeps going in that manner. So that's the first part here, is telling it when do we want this to initialize. The next part is it says test here, and it will continue to run the for loop as long as this test condition is true. And then the next part here tells us what to do in between. It's also important to note here that 2 plus symbols, one after the other, means add 1 to whatever variable you're using. So that's just kind of a quick way of writing it. You might see that a lot. You see it here. And vice versa, you can use minus minus to decrease by 1. So again, here's how we're using that. We're saying when power equals 0, and for as long as power is less than 255, increase power by 1 between each loop iteration. And you might remember this 255 was the max number that we can use to analog write. And that also corresponds to full 5 volts on. Okay, so let's say it's starting up. We're at the beginning. We just give it power. We already know that power is going to be equal to 0 because we set that. So we know that this for loop is going to trigger right away. So let's look at what's going on inside the for loop. First of all, you're going to see we're using the analog write command. And the syntax of this is analog write, and then you tell it a pin, and then you tell it a value. And again, this analog write needs to be in between 0 and 255 based on the duty cycle. So remember that again. In this case, and this is another reason why it's really helpful to use variables, we're using our light pin as our pin that we're going to be using to supply the power. But this time, instead of giving a constant value, we're using a variable here, which is power. So what we're saying is, right away, we want to turn the pin on at whatever level power is. So at the beginning, we know power is 0, so it's going to start the LED off. Next, what we're going to do is we're going to use the analog read command. And we don't have to do this to control the LED at all. But really what this is a way to install a feedback loop to see what's going on in the circuit. So in this case, what I want to do is I want to be able to tell what voltage is actually being supplied to the circuit, just as kind of a check. Okay, and what I'm doing is, so the way this works is you use the analog read command and simply the pin that you're using to read from. In this case, it's A5. So we're using that command, and what we're doing is we're saying that this variable voltage is equal to that command. What that does is once it reads it, it will store that value into this variable voltage here. And now we can use voltage to do things. For example, on the next line, you'll see we're using the serial print command to print voltage to the serial monitor. And that's what's going to allow us to actually see the value that's being read by the analog read command here. The next step after that, we're just using a delay command and 50 milliseconds. So we're just saying just pause. And that's useful because these things run so fast that if we were to just not use a delay command and say go, it would get really confusing. And you'll see when we run this, the data starts streaming incredibly fast. And it's hard to keep up with. So we put a delay in programs sometimes to slow them down so that we can actually see what's going on. Okay, so let's talk about what happens between this for loop and this for loop. Back up into the conditions here. So what's happening? We know power is at 0, right? So this is going to run once. It's going to set the LED to 0. We just talked about that. It's going to print the value to the serial monitor so we can read it. And then it's going to delay 50 milliseconds and then it's done. So what happens after that? Well, this right here is what tells it to do between the next loop. And what we're saying is add 1 to the value of power. So, okay, so it's going to do that. So now power is going to go from 0 to 1. And we don't have to worry about this condition here because this is just for the first time, the startup condition. Now the only thing that is checking is this one and this one, so we're adding it. So now it equals 1, which is still less than 255. The loop will run again, except this time power now equals 1. So when we write it, it's going to write a value of 1, which is some level greater than 0. It's not anywhere near full power, it's just slightly bigger. And then again, we're going to read it and then print it, delay. And then we're going to add 1. And then same idea. We're going to set the power, read it, print it, delay. So over time, and you'll see it actually happens fairly quickly, but over time, we're just constantly adding 1 to the power and then setting it or writing it to the light. So this is what's going to gradually power up the LED to full power. And okay, so let's talk about when it gets to full power. Once the value equals 255, which is full power, our test condition is no longer going to be true because power will be equal to 255, not less than 255. So once that happens, this for loop will stop running. It'll go to the next line of code, which is this other for loop. Now notice our condition here, we've set it when power equals 255. Well, we know that power must equal 255 because that's the condition that breaks this for loop. So that will trigger this for loop to run immediately after this one's done. And now our test condition is power greater than 0, and we're subtracting 1 from power between each loop, which is this power minus minus. The actual code between the for loops is the same. So you can just copy and paste that. That makes life really easy. That process is always the same. We're always setting the power and then reading it and then printing it and then delaying. So what this is going to do is it's going to trigger on, and it's going to gradually subtract 1 from the power. So the LED is going to gradually dim again until power equals 0. And notice that our condition is power greater than 0. So once power equals 0, this condition will break or become false, and then this for loop will stop running. And again, notice we've perfectly set it up. Power equals 0. This for loop will immediately kick back on. So you can see that this is going to cause our LED to gradually go from 0 all the way up to full power, back to 0, and it's going to just continue to run like that. So let's take a look at what this actually looks like when we start up our serial monitor. So first of all, to get the serial monitor running, what you need to do is come up here to the tools and just simply click serial monitor. And as you can see here, we're already starting to stream numbers. And you can see it's going fairly quickly, which is why I said it's important to put a delay in. But let's talk about what's going on here. So as the LED is going from 0 to full power, you'll notice that we're going from 0 to 991, which is pretty close to the full 1023. And it kind of depends on where you're taking your voltage reading from, but and then you can see as we get closer to 0 again, we're going back down to 0. So, and then again, immediately it's going right back up, and it's going to ramp up until all we're seeing is full voltage, in this case, which is 991, and then it's going to immediately start dropping back down towards 0. And I'll also include a short video of what this looks like on the actual circuit, so you can see the LED actually going from off to full on, back to off again. So okay, so this is a pretty basic example of how we can use analog read, analog write, and also for loops in our code. So that's going to be all I'm going to cover in this video. So in the next video, we'll talk about if statements, functions, and libraries, which are just a couple of other ways that we can use to control the program and the coding, and that also helps make our lives a little bit easier for the things that we want to do. So I'll see you in that video.